This is House Planning Help, episode 279. Hello, I'm Ben Adam Smith, and this is the podcast for you if you're interested in self-build, because I'm exploring what houses we should be building in the 21st century and trying to break down the major roadblocks that may get in our way. Coming up in this session, my guest is Lee Fordham, Associate Director at Architype, and it's an episode aimed at beginners. We're going through some common terminology. I do remember in my very first days, this is an episode that's aimed at beginners today, just being so impressed by other self-builders. It felt like they were part of the construction industry. They certainly had a confidence about them as well. So if this is you on day one, don't worry, it will come, and this sort of episode will really help. So my guest today does actually have a link to the podcast. And that's through his other half, his partner Lucy, who's worked with me. I was trying to think, it's probably something like 6 years that we've worked together. And this is certainly a team effort. It may be me talking now, but I don't do this on my own, thank goodness. And Lucy puts a lot of the show notes together. So if you've never been onto the website before, the idea of these show notes is to extract all of the learning points from every conversation that we have, and then also bring it to life even further with photos, videos, plans, things that we can't do in audio format in the podcast. And every so often we hear back from the various people that have been on the podcast. For example, a couple of weeks ago, Matt Barnett-Howland, the man behind the Cork House, was on the podcast, and he just sent through an email afterwards saying, your write-up is one of the clearest and most accurate so far. So that's Lucy, basically. And this project, it's had a fair few write-ups, being the Mansa Medal winner of last year, also on the shortlist for the Sterling Prize, big architecture awards, lots of write-ups. Well done, Lucy, and thanks for all your help over the years. Really appreciate it. She's also put together our list of terminology for today. And just before we launch into this episode, I wanted to point out that this is a very conversational run through these terms rather than clinging to a textbook for numerous reasons. It would be a bit boring otherwise. So we just have a chat through some of this. It's not going to be comprehensive, as we always say, although this is quite a good podcast that if you hear a term that you're interested in, the show notes may serve as an index and you can go on and have a look at some other episodes from there. As we've got quite a lot of terms and acronyms and various things to get through with Lee, we're just going to jump straight to the first one, which is passive house.
Yeah, so passive house, a lot of these terms, by the way, probably could be podcasts in their own right as well, which is
may have already been.
And may have already been. So passive house, so this is a standard that was developed in Germany about 30 years ago. It's based on physics. And the idea originally was to reduce the performance gap. So that's another one I think we can come on to, between how the building was designed to perform and how it actually performs. It's based on trying to get the building more comfortable, to reduce the energy demand of that building by basically having better quality in build and also gathering evidence of that build. So as an architect, we design using PHPP, which is Passive House Planning Package, which is a very complicated Excel document, but it allows us to design a building to ensure it achieves passive house criteria. And then a contractor then uses that information to build that building, and we gather the evidence to make sure that the components put into that building are correct. And then a certifier guarantees that, and that then gets certified.
And this is a rabbit hole and certainly something we have mentioned a lot. MVHR.
So this is an acronym for Mechanical Ventilation Heat Recovery, used in passive house but can be used in any other building as well. What it does is takes the air inside the building that has been used by its occupiers, i.e. it has CO2 in it, etc. It takes that air, extracts it from the rooms, and then it transfers the heat from that air to fresh air from the outside that is supplied to the building. So in every room you're getting fresh air pre-warmed effectively. For a domestic situation, they're probably about the size of a combi boiler type thing. There's various different filters you can use, but in general terms it reduces, they're about 90% efficient. Something like that. So yeah, great for any building really, but really good for passive house.
And one of the key benefits over natural ventilation being that you can almost control what your ventilation is in a given space and reduce moisture from bathrooms and...
Correct, exactly. That's right. And also the air is filtered, which is obviously really good, especially if you're in a densely populated area like a conurbation or something like that. So you can actually filter the air. And there's various different filters you can have for particulate matters and all things like that. So yeah, you can design your filters as whatever is in the external air. So that's the other advantage of it.
Foundations.
This is obviously a thing that sits under a building and transfers the load from the building to the earth. Now, there's various different sorts of foundations. The traditional one on a domestic building is what they call a strip footing or strip foundation. Footing and foundations are effectively the same thing. But depending on the ground conditions of the site, there are many different foundations. You can have pile foundations, deep strip foundations, raft foundations. They're usually designed by a structural engineer, and they are designed to transfer load from the building to the ground, depending on the ground conditions.
U value.
This is a difficult one. This has been a trouble for me to actually try and get this very concise, because it's a very complicated thing.
I was thinking that part of the challenge of this particular podcast is being able to describe it, because you know what all these things are, but actually telling it to someone, I bet you don't do that very often.
No, put it in a layman's terms. I've really struggled with this one. So I'm going to read this one
Go on,
and see how it comes across. It's a way of measuring the thermal resistance of a component, so i.e. a pane of glass, or a structure. So it could be a wall that's made up of different components. And basically it's the rate that group of component transfers heat through itself. And that's divided over the temperature between inside and outside.
Yeah, you see,
So
that's still
complicated, isn't it?
It
Basically, it's how thermally conductive a component is, or a series of components like a wall. And effectively, the lower the U value, the better it is. So building regs vary throughout the UK, but in general, a wall might be something like 0.13 of a U value. If you're looking at, say, passive house, you'll probably want to get down to about 0.8. So the lower the U value, the more insulation you have in the wall usually. And that's what it comes down to, is about how insulated is that wall or piece of glass or roof or floor. Every component, every external fabric has various U values that you have to adhere to.
This is something that I still don't feel I've got my head around 100%, but let's think if we're punching some of these numbers into PHPP and trying to get a complete thermal envelope. You can alter some values and make up for it in other areas. Is that a fair way of saying it, or am I getting confused?
No, yes, you can. You can absolutely do that. I mean, there are minimums we have to go to. There's a sort of a minimum or maximum you can adjust to. So your walls can't be 3. They have to be within a reasonable standard. But yeah, things like...
Because of building regs.
Because of building regs. Because if you had a really well-insulated roof and you didn't insulate your walls, that would be quite a dangerous thing, especially in a passive house where it's really well airtight. If you had one air component that wasn't well insulated and everywhere else was, that component would effectively act like a magnet for moisture and could potentially damage the structure.
But if you have something like a window, that's going to perform differently to a wall.
Correct, yeah. So that's why in a passive house building you have triple glazed windows, not double glazed windows, because their U value is a lot better than a double glazed window, for instance.
So are you trying to get that U value consistent throughout that wall? What's the goal of it?
Yeah, roughly you want things fairly consistent. They don't have to be exactly the same everywhere, but you want quite low U values, high thermal resistance in most components in a passive house, for instance. But in any house, you need it to be roughly the same everywhere.
Right, okay. I think I've still work to do there, but that's your hardest one so far. It's your hardest one. Let's move on to airtightness. Yeah, I'm feeling better now.
So airtightness, again, this could be quite a complicated thing, but for building regs, there's one requirement, which is a Q50 value, and that measures in pascals, which is effectively the pressure of an internal area. So when you measure for building regs, you air pressure test the building, and you either have it positively pressured, i.e. blowing, or negatively pressured, i.e. extracting. Usually only have to take one of those, so usually the best one, and that is your air test result. The building regs requires you get a result of 10 or less. But if you're talking about Passive house, that's a slightly different value. That uses the German way of doing an air test, and that's a N50 value, and that does air changes, how many volume of air changes in an hour. And that is a slightly different way to test, because that way you positively test, you put the building under pressure, you negatively test the building, depressurize it, and you take both of those readings and take the average. So that's a slightly different way to do it. And the requirement of that is 0.6 or less. So quite a lot less than building regs. Some people say it's about 20 times less, but it's not quite as easy to say that, because it depends on the volume of the building, how complicated the building is, etc., etc. So roughly 20 times, but it's not quite as easy as 20 times better, because it's not quite worked out like that.
And if we're looking at just a very wide description of air tightness, could we just say it's almost like eliminating the drafts?
Yes, which is what we want to do in a passive house. You want to try and make the internal environment comfortable with no drafts. So the higher the air tightness of the building, the better it is, effectively. And it's a relatively easy thing to do, but it just has to be thought through from the design stage. So the way we do it, Architype, when we do a detailed drawing, we have a red line that denotes where that air tightness is. And that when they're building the building, they know exactly what that air tightness is. They know not to damage it. They know not to put a screwdriver through it. All these things that happen on site, they take care of that. And then when we come and test the building, we know it's been looked after, and they've got a good chance of getting the air tightness.
Build systems.
This is something that Lucy, my partner, put on the list. I'd never even heard of.
What do you mean you've never heard of it?
We don't use things like this.
You don't use build system? Why not?
You just say, I'm going to do it in timber frame, or I'm going to do it in Brettstaple or CLT, or all these different things. And Lucy said, no, that's basically what a build system is. So I've learned something as well.
Or you can say construction
type or construction
type.
method. Yeah, that's what we would use. So I've never even heard of this one. So I've looked it up, and I'm sure your listeners know. But it's basically how you're building, what construction type you're using. So, at Architype, we specialise in timber frame, but we've done Brettstaple, we've done CLT, cross-laminated timber.
What was Brettstaple? I don't know.
Brettstaple is the use of timber that might not be structurally graded, but because it all comes together as one big panel, it's a way of using, not waste timber, but it's a way of using timber as a structural component. Sometimes UK timber is not great for structure, so it's a good way of using UK timber. But also, it's the standard stuff that you've got: insulated concrete formwork, precast concrete, in situ concrete. It's all these different ways you can construct masonry, brick and block, all these type of things. So it's just a way of describing what method you're using to construct.
I'm sorry, you do know this one. Maybe not under that guise.
No, but, not under. It was the title that caught me out.
Prefabrication.
So effectively what it is building something off-site and bringing it to site. That can vary from a whole house being brought to site and plugged in, bathrooms complete off-site, plumbed in, all screeded and all tiles on the wall, plumbed in, everything ready, and it's just brought to site, put on this where it needs to be, and everything's just plumbed in there and then. So effectively, in simple terms, it's making something off-site and bringing it to site. The advantage of that is obviously you're building that thing in a factory. You're not affected by the lovely English weather and the UK weather we have here. It usually results in better quality, and in that case, everything works usually better on site when it's brought onto site.
Zero carbon.
Again,
were you able to do this off the top of your head, this one?
Yeah, I was able to do this off the top of my head, but this is a difficult one to answer because there's various connotations and understanding of what zero carbon is. So zero carbon is effectively offsetting the energy use in a building. The better your building is, i.e. passive house, the less carbon you have to offset because you're not using as much energy. So there's various different connotations. You can have zero carbon in use, which is just the energy that is used once you've built the building all the way through to the end of life of that building. So that energy you're using to heat it, to have hot water, to have showers, all these sort of things, that's offsetting that energy use, i.e. offsetting that carbon. But also there's embodied carbon or sequestered carbon, and that's basically taken into account everything to do with the design, the construction of that building, plus the energy and use of that building, and sometimes the demolition of that building. So that is a lot more complicated to account for. But there are tools out there that allow us to understand exactly how much carbon, for instance, it takes to get a tree from Germany to put into a timber frame, get brought to the UK. So all that carbon for trucks and all that sort of thing.
Well, I remember coming up to the Enterprise Centre halfway through construction, and as I checked in, they were saying that this data would be used, that I would actually be on the footprint of the
Correct.
Because, I mean, fascinating to that level. So I don't think many people are doing that. But
No, there's not many people doing that. But that is probably the way it's going to go. If we have to reduce our carbon footprint as the UK, but also as a world, we're going to have to start doing something a bit more out there, which is basically what they did at UA, what Architype did at UA, was basically take the count of every piece of carbon footprint that was put into that building. But usually, as I say, usually what it is just the energy use of the building. So from when occupier moves in to when the building is demolished, it's that energy. That's usually what they talk about carbon offsetting.
Now, Lucy's put this one in. Did you have to look up custom build?
A little bit. I did have to use up a little bit. But effectively, there's two different definitions of this that I've just looked up on the internet. One is obviously the self-build, which we're talking about, which is basically find a site and build the building and design it yourself all the way through, or get an architect and contractor to do it for you. That's still classed as self-build. Some people think that's also called custom build. However, custom build is more where the site already has services to it and is usually done by, say, a developer. They may have prefabricated houses that then you can choose from. So you can choose the shower suite or the finishes, all these things in it, and then it comes to site. So it is personalised to yourself, but it's made off of production line effectively. And that's sort of the difference. Is one is you find your own stuff, and the next one is the site's already got the services to it, and you just choose a component.
It's trying to be the halfway house, really,
Yeah,
isn't it?
exactly.
Because self-build, I mean, that is a misnomer in the way that most people do it. As for my project, I commissioned it, but you could be doing it with your own hands. But I think custom build is just trying to say, we'll take a few decisions off your plate.
Yeah, exactly. That's right. Make it slightly easier.
Solar shading and brise soleil.
Yeah, solar shading and brise soleil are effectively the same thing. So basically what it is a horizontal component that sits over south-facing glazing, basically. And that horizontal component can be a roof overhang, it can be an external canopy, it can be a series of louvers. And the idea is to stop the sun coming in the summer months when we don't want to overheat the building, but to allow the sun and the heat to come in the winter months when we do want that heat to come in the building and warm us up. You can also have brise soleil on the east and west facing, but they're slightly different. They're usually a vertical component rather than a horizontal component, and that's really all to do with just where the sun is at what angle in the sky at certain times of day and certain times of year.
And are you careful with your west glazing as well? I mean, east too, but west is always for us in the UK.
Absolutely, definitely. The one of the most important things when you're designing or commissioning a build is to make sure that whoever's designed it have got the orientation of that building correct. What we really want in an ideal situation is a south-facing facade, so most of the windows on the south side. We don't really want too many on the east or west because they're quite hard to counteract the sun in the sky effectively, and the overheating issues you can get and glare issues you can get. So really, in an ideal situation, we want that building facing south, and we can control the solar gain a lot easier that way.
Design team. Now, on the face of it, I'd say this is an easy one, is it? Because we're about halfway.
This is an easy one, this one. So this can be made up of, obviously, an architect, of which I am, but a structural engineer, civil engineer, M&E, project manager seems to be quite a popular one now that people are using. And that's the core of a design team. But then you can go out to landscape architects, ecologists, arboriculturalists, all these different people make up a design team on a big project. But the core people you really need is an architect, a structural engineer, and M&E, mechanical and electrical ventilation experts, really. They're the core for a house, I would suggest.
Renewables. Okay, you've got a couple of easy ones here.
Oh, these are easy ones. So renewables is a technology that generates energy. So you can have photovoltaics, you can have wind turbines, wave and tidal power is becoming more popular in the UK, hydropower, gas thermal power, those type of elements.
Although it looks like our next term air source and ground source heat pump has been taken out of renewables.
These could be classes. Some people class as renewables, some people don't.
Oh, that's interesting. Okay, I learned something.
So an air source heat pump is basically taking energy from the temperature of the air. So any air that is above 0 degrees has energy in it. So we can take that energy and transfer that into heat, effectively. That heat can be taken as heating your house up or giving you hot water or anything like that. They're obviously put on the outside of the building because they're using the external air. They're probably about the size of a washing machine, that type of thing. They're quite quiet, they don't make a lot of noise, and they're fairly efficient and fairly cost effective, I would say, an air source heat pump. The other one is the ground source heat pump. Works in exactly the same way. It just doesn't take the energy out of the air, it just takes the energy out of the ground. Probably a bit more expensive to do. There's two different types. One that spreads the pipes out vertically, and they're a lot more expensive, so you have to pile those into the ground. The other one spreads them out horizontally, but obviously you need a large piece of land to do that. And like I say, they're more expensive, but all work in roughly the same way, basically taking energy either out of air or the ground and transferring that and making that into heat.
So we're going to look at architectural drawings next, but specifically the different ones that you get. So
yeah, this was quite a surprise when as an architect you go and consult with people, and I read a drawing like anyone reads a book.
Yeah.
But then when you put a plan in front of someone and someone says, "What's that archy thing with a line?" You say it's a door. You realise people can't read drawings as well as you think they can.
Architects, your core skill is about space, isn't it?
Correct.
And I think someone else coming into this, certainly when I was looking at this plan, it's very difficult to know if someone draws a sofa or whatever, is that sofa enough? Can I put my feet up without hitting the walls
absolutely.
or whatever? But you guys, you got it instinctively. So far away with this one.
So this is basically the difference between the different type of drawings we use. So effectively a plan is looking down on something, and you take, say, a building, the roof off it, and you've got a plan of all the walls, the doors, the roofs, the windows, everything are there. You work it out and you're just looking down, bird's eye view. Obviously then you can take the ground floor, the first floor, you just cut away. So that's a plan. That's quite an easy thing to do. An elevation is you looking at the front of a building, and you can take all the different elevations. Usually an architect would say if it's a south elevation, that means that elevation is facing south. So it's the elevation that faces to the south. And that's just a flat drawing of what the building looks like. The other one is a section. This is the one that Lucy always struggles with. So basically you take a building and you slice it down the middle like a cake, and you're looking at the building in sections. So effectively you're looking at the component of the walls, the floors, the roofs, everything in that building. You've basically sliced it down the middle and you're looking into it.
And the challenge here for us non-designers is, how many of those do you do? We can understand elevations, you walk around the building, but...
Yeah, so it depends what you're trying to convey. So if a planning set of drawings, you probably don't need too many sections. But if you're trying to tell someone how to build a building, then you would take a section of every area that's different, because you're trying to convey to a builder or a contractor how that building goes together. And then basically a section, then you zoom in to various areas, and that creates a detail. And then details can be various scales. They can be 1 to 10, 1 to 5, 1 to 1, 1 to 2. And they basically then give the contractor, whoever's building the building, a very in-depth analysis and instruction basically of how to build, how to construct that building. So it will tell them where the air tightness line is, where the insulation is, how wide cavities need to be. All these things that a builder needs to know will be on that detailed drawing.
Have we pretty much covered off
I think
architectural
so.
drawings?
I think so.
Soft landings, performance monitoring. Now, I would question whether this is more in what you do rather than a self-builder. Would this come into...
I think most people should do it, whether they're self-builders or not. It's making sure that once the building's constructed, that the operator of that builder, the user of that builder, knows how it goes together. So if you're a pure self-builder and you've done the whole thing yourself, obviously you should know how that happens. But if you've commissioned someone to do it like you did, Ben, you'll still need someone to tell you how that works at the end. It's like getting a new car. You get an instruction manual with it. That's part of the soft landings thing to do it. Then performance monitoring is basically monitoring that building. Again, most people should be doing this on their building. It's quite a simple thing to do, but you want to know, is your internal temperature correct? Is it 21 degrees? Do you want to be at 21 degrees? Is it relative humidity in there okay? Is the CO2 okay? All these things help you understand your building. So they all come with our performance monitoring on the buildings. But you can buy these things fairly cheaply. I'm just looking at one up there. That
I'm just thinking how many. I was counting them in my house. How many have we got? Eight or nine of these things. But Kay probably hates them. She probably hates these things. I don't know whether Lucy likes these ones.
But that one on the wall there is like 25 quid, you know. And
so yours is, that one to me looks like it's going into a computer somewhere and monitoring
it's just
something.
a USB. Yeah. You take it off, it monitors relative humidity, temperature, CO2. It's got a USB connection on the end of it. You plug it into your computer. There's an app with it, and it downloads all the information, gives you all graphs. It's very
you
simple
love those
thing
graphs.
to do. I love the graphs.
Yeah, mine is more a visual. Come into a room. How are we doing in here?
No, yeah, we try. I mean, it's black. We try and hide it as much as we can. But.
Yeah. Tender.
Yeah, so this is. There's various different types of tender. You can tender for a design team, or you can tender obviously for a contractor, and the way you tender depends usually on the contract type you're going to have. But in very simple terms, it's a set of information that goes out to someone. They put a price against that, and then it comes back with the price and probably a quality paper. And then depending on what your priorities are, whether if you've got a limited budget, you might score it 80% cost, 20% quality, because you haven't got a lot of money. So effectively that would usually mean the cheapest one wins. Or you can do it the other way around. You could do 80% quality, 20% cost. In that way, the best one would probably be not necessarily the cheapest. So it really comes down to what your priorities are and what you can afford. And basically it's a set of information that goes out, comes back, is scored, and that allows you to tender for either design team.
The key thing here is making it comprehensive.
Correct.
There's no point sending it out if actually you're going to need a load more stuff.
Yeah, absolutely. Yeah, a full set of information is always best. I mean, some people do go out on planning drawings, but if you go on planning drawings, people are just going to price risk. And if they price risk, it means the price goes up, and it's probably going to be more expensive. If you actually get all the drawings, all the details we talked about before already, then it goes out for tender. There is no reason to price risk because everything's already been drawn.
We've got a few around windows here, which you have mentioned.
I have mentioned, yeah. So this is just basically looking at several parts of the window, which is obviously...
I'm still not sure. Sill I can handle, I think.
Sill is obviously the bit at the bottom. The head is the top of the window where it meets a wall, effectively. So where the frame meets the wall, the head detail is that detail, and that can be internal or external or both on a detail. The jamb of a window is just the side of a window. They call it the jamb of the window, but that just means the side of the window. And then next to that, you've got the reveal of the window. So that can be internal or external. So the internal reveal is usually plasterboard in a traditional building. The external reveal might be brickwork or timber, something like that. And
these reveals can actually be giving a little bit of shading as well.
You're right. Depending on where that window is within the thickness of the wall, if it's a long way back from the external side of the building, then yes, you will get quite a bit of shading to that window. But it just depends where it is in that window, in that wall. And then mullions and transoms. Mullions are basically, when you look at a window traditionally on a Victorian building or something, the vertical bit in the middle of the window is called a mullion. The bit that goes horizontally is called a transom.
Roof parts. Is this our last one?
This is our last one.
Okay.
Roof parts, again, it's very simple. The eaves are the bit that overhang a wall. Usually, if it's a sloping roof, it's the bit that overhangs where the gutter is. The bit underneath that's usually a horizontal section underneath that, is the soffit. So that's the bit you can look up and you see the underside. That's called a soffit. The ridge is obviously the bit at the right at the top of the house, either where two pitches come together or two slides come together, or it can be a single ridge. And then the verge is the bit at the sides. So on the side of a house, usually you have a barge board or a bit of wood that goes down the side. That's called a barge board. A parapet is a bit of usually wall that sticks up above a flat roof. And then the trusses are the bit that actually make the roof. So they're usually made of wood.
And I think it's quite interesting for me, having gone through this, thinking we're aiming this at beginners, but it's quite surprising sometimes. You can always learn something. There's always some bit of terminology that either you've learned and forgotten, and I know this is your profession, but do you still come across some things? Maybe not these terms here, but
let's go through the list. The build system was one I hadn't heard of, so yes.
Well, I'm sure there are probably all sorts of different ways of explaining, complicated. Let's get another 10 terms to describe the same thing.
Absolutely. But yeah, I think there are things I haven't heard of, obviously, but I think there's things that we take in the industry as read, like a U value. We just talk about it. Yeah. But when you actually come to describe it, it's quite a difficult thing, because I just know what a U value is, but trying to describe a U value is quite a difficult thing. So it's made me think, definitely.
Also, as self-builders, sometimes you can get absolutely into everything. You're wanting to understand like you do, and then you get other people who, they're not really interested in U values. They just I want the passive house. You tell me what windows we need, and that'll be a number on a piece of paper. But
absolutely,
it's interesting, that.
Yeah.
Well, Lee, thank you very much for your time and for going through that list. And enjoy that. Thank you.
I hope it helps. Thank you very much. Cheers. Bye.
Get more online at houseplanninghelp.com/279 for this episode, where you'll find our summary. We've got a few photos that we've added in there to bring things to life. Also, if you've got a comment or you'd like to ask a question, you can scroll down to the bottom of the show notes. There's a place to leave them there. We'll link you across to Architype, which is where you'll find Lee on a day-to-day basis. houseplanninghelp.com/279. Finish up on a hub update, and we've added another live training session. This was with Stephen Gurney from Eden Insulation, and the topic was off-site semi-modular construction. Looking at some of the aspects that change slightly in the design process. You've got to make a lot more of the decisions up front to make sure you've got them right. You've got to pay attention to things like access, because if you're going to get a crane to site or articulated trucks, you need to make sure you can actually do that bit. The site needs to be prepared well. Don't penny pinch at this stage. We learned all sorts of other things, foundations. Also, maybe you overlook this, but it's going to happen quite quickly. So you've got to be able to move on from there. You've got to be able to pay your bills. But I guess the big upside to do with having your panels arriving pre-insulated, also having the air tightness largely done. It's just your windows and doors for this particular system. And in the winter months, this can be great to just accelerate your build on. So lots more in our latest live training session, which we've now got in the archive in the hub. If you're one of our members, or if you're thinking of becoming a member, you can find out more at houseplanninghelp.com/join. Next time, John Bootland is my guest. It's the last in our mini-series for beginners, and we're looking at the Passive House Standard. That's your lot for today. Thank you so much for being there. The House Planning Help podcast is produced by Regen Media, content that matters.